Here's a quick video reviewing how to run Factorial ANOVA. This type of ANOVA allows you to see if a combination of independent variables has an effect on the value of a dependent variable. This means that you can have multiple independent variables or factors. Also, these factors can have multiple levels. Here we have an example from a study that investigated whether gender and age had an effect on memory. We can find out what kind of ANOVA we can run by clicking on Variable View here at the bottom and reading more about our variables. Here we see that gender is our first factor. This is the gender of the participant. And we can see how many levels this variable has by clicking on this blue box with the ellipses in the values column. So this means that there are 2 levels in gender. If there's a 1 in the box in the data set, that means that that person is male, and 2 stands for female. We can do the same thing for age, which is our second factor. This is the age of the participant, and if we click on the blue box with the 3 dots, we see that there are 2 levels of this factor as well. 1 stands for young, and 2 stands for old. Finally, we have our dependent variable, which is memory. This is what we're trying to measure. And for this study, it turns out that memory is defined as the percentage of correctly remembered words. Variable view gives you a lot of good information, so be sure to go to that view anytime you open a data set. So by looking at this, we can tell we have a 2x2 between subjects factorial ANOVA. That's because we have 2 independent variables, and each of those had 2 levels within each factor. And then also we know it's between subjects because for both of these, you can't have overlap in these factors. So one cannot be part of the male and the female category, and one cannot be part of the young and the old category. That makes both gender and age between subjects factors. So to run this 2x2 between subjects factorial ANOVA, we click on Analyze, General Linear Model, and Univariate, and you'll get a screen that looks like this. So we know that memory goes in the dependent variable box, since that's what we're trying to measure, and gender and age can go in the fixed factors box. Then we click Options, and you should get this box. We want to get the estimated marginal means for everything, so we move everything over to the Display Means For box. And to run the post hoc test, we click Compare Main Effects and choose Bonferroni. Finally, we can also click Descriptive Statistics and Estimates of Effect Size to get those in our output as well. Our significance level is always set at 0.05 as the default, so that's good. And then we should be ready to run the analysis. So here's our output. If you pay attention to the left, this serves as a kind of map to help you go through all of these different boxes. Specifically, we want to look at the tests of between subjects effects box, where this red arrow is pointing. Here we can assess whether we have a main effect or an interaction of these variables. So for our first factor, our first independent variable, gender, we see that we do not have a significant finding. So this means that gender did not affect one's ability to remember words in this experiment. However, if we look at age, and we go over to the significance level, we do see that this is below 0.05, which means there was a significant main effect of age on one's memory. Then finally, if we look at gender and age, which is the interaction effect, we see that the combined factors don't have an effect on memory performance. So to look at this main effect more closely of age, which was our only significant finding, we would go down to the age of the participant and go to the pairwise comparisons. This is where we ran the Bonferroni post hoc. So here we can compare the mean difference and see whether those differences were significant. So we do see that there is a significant difference, and if we look at the mean and standard error estimates box up here, we see that young people had an average of 83% correct words, or 84% correct words, while older people only had about a 60% performance. So because this difference is significant, we can say that younger participants did better on the memory task than older participants did. Only age had an effect on their memory. Now this part, when we probe the interaction, isn't necessary for much of what you're going to be doing for this stats course, but here's just some information on how you can probe the interaction. So if you pay attention, you can look at the main effect for each of these factors. You have one for gender, but because this did not turn out to be significant, it's at 0.06, about 0.07, we don't really report that. We just went through the age finding, which we would report, but we don't seem to have similar boxes that tell us whether those differences are significant for the interaction. To get that, we would run the analysis again, and it saved all of our settings from before. All of these are the same. But instead of clicking OK here, I can click Paste. So what you should get is a box that looks like this. This is called your syntax. Alright, so here you can manipulate what you get in your output. To probe the interaction, you can type in the same lines of code here for your interaction in this way. So you would type compare, and then for the interaction, you list the first factor that you want to look at. Gender, space, and then the same pieces of information here telling it that you're running the Bonferroni post hoc. Then I would just copy this line and enter it in beneath it and change this gender to age. Then you would select all of this and run it again. So now I've run the whole Factorial ANOVA again, but if you can see here the difference that this information was left out from the first analysis, I now have two lines that will give me separate pairwise comparisons for those, for the interaction. So if I look here, I see no significant differences based on the combination of gender and age, and I'll see the same thing here. So if we look at these boxes, if we compare young and old participants separately, young male participants and young female participants don't differ from each other. Old male and old female participants don't differ from each other. All right? But if we look down here at the second pairwise comparisons box, we see that young and old did have a difference no matter what gender you were. So again, that step is extra. You don't really need to worry about that for what you're doing for this stats course, but it's good information to have moving forward. Alright, so this was a quick video reviewing how to run Factorial ANOVA, and there's another video that we have to help you graph those pieces of information.